This is Euclid Book 10, proposition number 41. If two straight lines, incommensurable and square, which make the sum of the squares on them medial, and the rectangle contained by them medial, and also incommensurable with the sum of the squares on them, be added together, the whole straight line is irrational, and let it be called the side of the sum of two medial areas. Okay, what does all that mean? Well, here's the diagram. You got a square up here, a rectangle down here. You got KH, GF, DE, and a line down here that says A, B, and C. That's what you've got. Okay. Now then, for let the two straight lines AB, BC, incommensurable and square, and satisfying the given conditions by Euclid Book 10, proposition number 35, be added together. I say that AC is irrational. Let a rational straight line DE be set out. Okay. We're going to set out DE as a rational straight line. And let there be applied to DE the rectangle DF equal to the squares on AB, BC, and the rectangle GH equal to twice the rectangle of AB, BC. Whoa. What is all that? Alright. We're going to make a rectangle called DF. That is rectangle DF. Okay. Now then, what about rectangle DF? Its area is going to be equal to the area of the squares of AB, BC. Okay. So, we're going to make two squares. The first square is AB. That means that all four sides of that square are going to be the length of AB. We're going to make yet another square. It's going to be BC. All four sides of that square is going to be the length of BC. The area in this square and the area in this square added together is going to be this. That's what that means. Okay. Now then, alright, now we're going to have yet another rectangle. It's going to be called GH. This is rectangle GH. Now it looks kind of like a square up here, but actually it's a rectangle. Okay? Now, the area inside of this is going to be twice the area that you would have. You say, well, wait a minute, twice the area of what? Okay, well, the what is, we're going to make a rectangle. Two sides of that rectangle are going to be the length of AB, and two sides of that rectangle are going to be the length of BC. So, the area in that rectangle that I just said to make, which was AB and BC, this will have twice the area of that rectangle. Okay, and you can draw this out for yourself. Go for it. Therefore, the whole DH is equal to the square on AC. This is by Euclid Book 2, proposition number 4. So, what is the area of the whole DH? This whole thing right here, that's the whole area. It's going to be the same amount of area, all of this together is going to be the same amount of area as if we drew a square and all four sides of that square was the length of AC. Okay. Let's go on. Now, since the sum of the squares on AB and BC is medial, okay, so the area inside this square and the area inside this square added together are going to be medial. Okay. And that area, which the area of AB, the area of BC, added together, that area is going to be equal to DF. Okay? Therefore, DF is also medial. So, this rectangle here is medial. Okay? And it is applied to the rational straight line DE Therefore, DG is rational and incommensurable in length with DE. Okay, this is by Euclid Book 10, proposition number 22. So, DG is a rational line. It's incommensurable with DE. Okay? Now their squares are commensurable, but the two lines are not. Okay. We got it now. And let's see. For the same reason, GK is also rational and incommensurable with length GF. Okay. GK is rational and incommensurable with GF. Okay. So this line is rational and it's incommensurable in length with this. And since this is the same length as this, then this line is rational and incommensurable in length with this. Okay. And since the squares on AB and BC are incommensurable with twice the rectangle ABBC, DF is incommensurable with GH. This is incommensurable with this. So that DG is also incommensurable with GK. Okay. And this is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 11. Okay. Alright. DG and GK are incommensurable. So this line is incommensurable with that. And they are rational. Therefore, DG and GK are rational straight lines commensurable in square only. Therefore, DK is irrational and what is called a binomial. So DK is a binomial by Euclid Book 10, proposition number 36. This whole line right here is a binomial. See that? That whole line is a binomial. Okay. But DE is rational. I'm sorry. But DE is rational. Therefore, DH is irrational. Okay. So, all I can think here is that well, saying DE is rational, so I'm thinking that line DE is a rational line. And I'm assuming that this whole line here is going to be the same length as HE, so this has to be DH right across here. And it's irrational. Therefore, DH is irrational, and the side of the square which is equal to it is irrational. This is by Euclid Book 10, definition number 4. But AC is the side of a square equal to HD. Okay. So, AC is the same length as this. AC is this length. Okay. So that means that AC is irrational. This line here is irrational. Therefore, let line AC in this case be called the side of the sum of two medial areas. This is the side of a sum of two medial areas. And that is the whole proof. I will tell you more in a future video. Stay tuned.